Okay, next is pivot table. Pivot table is something that I hope you're familiar with from Excel, right? So you have categorical variable as rows, categorical variables as columns, and then you have statistics for each cell. That's what this one does. So we have pd.pivot table, okay, and here you start with the data source, which is a data frame, and then values, that's your numeric columns. Values must be numeric, right? And then index, that's your categorical variable. Okay. And the margins equal to true if the statistics, you want the statistics for the margins to also appear. And then we have the keyword, the aggregating function. AGGFUNC is the aggregating function. What kind of aggregating function you want to apply to the pivot table? So here I'm using the median, and the NP specifies that use the NumPy median function. Okay. Margins didn't really. Okay, and then I have a round too. So let's say that we want mean. I don't know why margins didn't work. Suppose if I say margins. Oh, margin did work. Okay. Okay, so you have all, that's your margin equal to true. So there are only two values for state, Georgia and Tennessee. So let me put it back to median. Okay. Your turn. Prepare a pivot table for the median of age and weight for smokers and non-smokers. Okay. So we have PD, and then pivot table is lowercase p, pivot table. Okay. So the first item in pivot table is, take a look at this example, the data source. Right? The data source here is DFQ17C. Next, we have to specify the numeric columns upon which the aggregating function must be applied. Okay. So what are those columns? So values equal to, so we have to give values equal to, and then we have to give index equal to. Okay. So values equal to here will be age and weight is W is uppercase. Okay. Now index equal to smoker. So data source, value columns, and the rows have been indicated. And then we need to do one more thing, which is what is the aggregating function we want? Aggregating function is AGGFUNC. Aggregating function. In this example, we had only one aggregating function, which is the median, right? But here we want median and standard deviation. I thought median. Oh, median age. So let's say that we want both median and standard deviation. Okay, so AGG func is NP dot median, right? So that's going to give us the median okay. So if you want 2, then you have to give that as a list. Now, if you use NPSTD, then remember the default is population standard deviation. STD. Oh, okay, so that should be just STD. Okay, so this is from the pivot table. The aggregate function comes from pivot table, so you don't have to specify the parenthesis. Okay, and now of course if you want to round it, you can specify round here, and that will round it to the number of decimal places that you specify. So pivot table function is very useful for descriptive analytics. So if you have data set and you want to prepare a table of mean grouped by different variables, then you use like that. So you have 2 statistics here, the median and then the standard deviation. All right, so moving on, so we have correlation and covariance. So CORR is your correlation function. So if you specify, so here is our DF7. So DF7 dot CORR will compute the correlation of all combinations. So there are 3 numeric variables. So it's going to find the correlation of the 3 variables against. So across the diagonal, okay, a correlation between itself is 100%. So you're going to have 1 across the diagonal, and off diagonal will be symmetric. Okay, so correlation between V2 and V1 is same as V1 and V2. So it's going to find the correlation of all the pairs. And if you use COV, that's going to do the same, but it's going to give you the covariance. Okay, this is 8. So let's say do it for 7. So it'll give you the covariance. So when you have covariance, diagonal will be variance, because there is no covariance between V1 and V. Well, covariance between V1 in itself is variance. It's not covariance. So you across the diagonal you get variance, and off diagonal you get covariance. Now, if you are interested in the correlation between just 2 variables, then you can specify that. So 1 variable dot CORR of the second variable. So then I'll give you the correlation of just that 1 single pair. So df7.v1 dot CORR df7.v2. So that's a correlation between that just 1 single pair, V1 and V2. Okay. And then we have correlation with, so that would be just 1 column in the CORR. So if you say df7 CORR with V2, then you get the correlation column of V2. So that's that one. Okay. So now we want find the correlation between age and weight. So we have DF Q17C. Okay, those are the only two. Those are the only two numeric variables, so you don't have to specify anything at all. Then it's going to give you this matrix. Now, if you do specify DFQ17C dot age, right? So like that. Then CORR DFQ17C weight. So that won't give you a table, it will just give you that one single value. Okay. All right. So we have completed chapter 5 sort of. Okay, we covered a lot of stuff. So we started off with pandas series. Okay, so there are two basic data structures, series and data frame. Series is just one single collection of values. It has to be the same data type, okay, and it is associated with indexes. Then you can access the index. You can iterate over the, itr items will give you the index and the value, and then you can do all sorts of stuff with that. And then you can have implicit and explicit indexes. So implicit will be 0, 1, 2, 3, or you can specify your own index. And you can have arithmetic operation with scalars. So if you take a series and multiply by 3, then it's automatically, it will multiply all the values in the series. So that's the universal functionality. And then you can use masking, and you can specify data time data in the series. Okay, so we looked at pandas timestamp functions, how to compute differences of time, range of time, and then convert the range into different time units. Okay. Then we looked at pandas data frame and adding new columns, new rows. New rows is concatenate. Okay, adding columns will be just putting a new variable name in the data frame name. Deleting columns with del or drop. Okay, data frame dot drop. Now drop is not permanent. If you want it permanent, you have to say in place equal to true. Whereas del is permanent, or you can use dot pop. That also you can use. And you have implicit and explicit indices, and then you have the dot lock and dot ilock way of indexing. Then we have various data frame functions, numpy functions, np.exp, np.power, np.mod, and things like that. Okay. And then I don't know, did we do fill functions? I don't think we did fill functions. We will be doing fill functions later. And then we did apply today. So you define your own function, you use apply, and then compute descriptive statistics. So there's lots of stuff here. It's important that you revise, go through the class notes and the code, because it's easy to just all get mixed up. Okay, it's a good idea to go over it a couple of 2-3 times to make sure that you understand what's going on.